Hi, welcome to the Team Topologies live stream of teams. I'm Matthew Skelton. I'm the co-author of the book Team Topologies. It's good to be here again. And we've got a super exciting session today. Just one or two things I want to mention first. The first thing is the Team Topologies community. And we've just started a new group, the Team Topologies community. I'm going to share my screen and show you that in a second, which is this one here. So we've got a new group all around Team Topologies AI and data, which is particularly suitable given the topic of today's live stream, which is all around effective machine learning teams. And I've popped the first post in here all about that book, and we'll cover that just in a few minutes with my two guests. But hey, if you're in the space around AI or data, machine learning, anything like that, then hop into our Team Topologies community. It's free. Join. There's plenty of stuff going on. We've got a whole bunch of different groups in here covering leaders, fast flow meetups, cloud, platform engineering, product centric, embedded software, blah, 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 a whole load of stuff. Telco, financial services, lots of different focus areas and plenty of discussion going on. And we've got more and more people joining each week. So whether you're interested in AI data or any of these other things, like head over to community.teamtopologies.com. I'll just pop a banner in there so you can see what that looks like. community.teamtopologies.com and join up there. And there's plenty of practitioners and people thinking about these different challenges and so on, and really diving into the topics. So it'd be great to see you there. And there's one particular topic this week which was quite interesting. So Semin, who's one of the Team Topologies advocates, asked about, do you have any resources for AI ML disruption around Team Topologies? And super question, right? Like, it's super topical. There's a few different things that have popped up recently. The first one is a great talk by Patrick Dubois um, at the AI for the Rest of Us conference in London a few weeks ago. So Patrick Dubois, of course, one of the key people behind the whole DevOps movement starting around about 2008, 2009. And his attention is now partly on AI and how that works for engineering teams and so on, and how we can use it. And so he's got a really interesting talk around thinking about how to evolve your organization in the context of generative AI. So thinking through Conway's law, this socio-technical mirroring that tends to happen in organizations, and how might generative AI change that or be affected by it or whatever. A super interesting talk there. That's linked from the discussion thread. Mark Rendell linked that. Thanks for that, Mark. And then the other thing is a talk that I gave just earlier this week around a kind of AI savvy operating model, thinking about how generative AI can enhance knowledge work, and then how we might use some Team Topologies principles to think through effective ways of working in that kind of space. And it was interesting for me to think through some of these principles from, like, using some of the Team Topologies ideas, but also bringing in like a kind of a humane, a kind of care for the human being in this, in all of this, and helping to guide some thinking. So we've got some really interesting comments back from people. It seemed to be very useful. So it's worth checking that one out as well. The video of that will be online, I think, soon. The slides are there now. Okay, enough of that. There was an interesting webinar that I did with Manuel, my co-author. That was earlier this week, and the recording is going to be online soon. So if you head to the Team Topologies events page, as always, teamtopologies.com/events is here. Then you'll pick up all the stuff that's going on. And there's just heaps and heaps of stuff happening. And obviously a lot of these have got video recordings available afterwards. So even if you didn't catch it at the time, sign up again and you get the video recording, obviously. This one in particular was kind of useful here around transitioning from project to a product operating model. That was with me and Valyonchev. Again, worth like checking that out if you're in that transition from project centric to product centric. There's a lot of stuff we covered in there. Loads more to cover, but a lot of stuff we covered in there, which was really useful. Okay, let's get on to the main item. So I am. Let's take my screen, stop sharing. There we go. So I'm super happy to be joined today by two of the three authors of the book Effective Machine Learning Teams. So let me just introduce David and Dave.
Hi, Matt. Thanks for having
us. Hi, it's good to see you. And you're.
Hi, Matt.
What time is it for you? What time is it for you now?
8 p.m. here in Melbourne.
8 p.m. in Melbourne. So it's the other end of the day for me. 9 a.m. for me. But thank you for doing it. I'm between. We're between you and a beer or some nice food or something like that, right?
Yes.
So thank you for joining. Really appreciate it. Just take that events thing off there. There we go. All right. So one of your let's just talk about the book. But one of your co-authors is not here today, is she? So Ada is on a bit of a break, but it's worth. We'll mention her properly in a little bit, I guess, after we've done some intros. So just to get started, just give us a quick intro each, like who you are, what your background is, why you wrote the book, and kind of what you're excited about, I guess, what you're up to now. David, first, maybe?
Yeah, sure. Thanks for having us here, Matt. It's a pleasure to be here. So I'm David. I'm an engineering manager in Xero AI Products Group. So Xero, we're in the business of accounting, helping customers, do their accounting jobs to be done, such as reconciling invoices, statement lines, and cash flow forecasting insights, things like that.
I can vouch for Xero being a really good product because we use it literally every day for about 10 years or 8 years or something. So yeah, I mean, this is not product placement, but yeah, I'm pleased to be able to have you on because I really appreciate the engineering that's gone into it.
Amazing. Yeah, glad to hear that. So data and AI in the intersection of engineering, I think there's a lot to be excited about. Like there's so much that we learn from software engineering, building digital products, and also the AI boom of the past few years. Being able to kind of bring it all together is a real joy. I think taking what patterns have worked and helping people solve problems. So that's what the book is all about. The one that Dave and I and Ada wrote. And yeah, really happy to be here. I'll throw it over to Dave.
Thanks. Hi, I'm Dave Colls. We use Dave to disambiguate between the two Davids. My contribution to Effective the Machine Learning Teams is based on my time leading and growing the ThoughtWorks data and AI practice in Australia, where we worked with many organisations to build ML products and improve ways of working around ML and AI and develop organisational strategy. Right now, I'm working with NextData on what the intersection of ML and AI and data mesh looks like. So that's a pretty exciting, evolving space as well.
That's cool. Thank you both. I'm just going to head into the comments. A second. We've got just good morning from Riga, from someone who's joined on LinkedIn. Hi, good to see you. Hi from Alex. And the link to the AI Savvy talk, I'll put in the chat. I think that ends up getting pushed onto LinkedIn and other places. AI Savvy operating model. Can't spell. It's way too early for me. I can't spell properly. There we go. Let's see if that posts onto LinkedIn. It should do. There we go. I think we should share a copy. We should share a photograph of what the book looks like. So I'm just going to do that right now. And I found a really great picture of you, David. I've showed you this already, right? This one. Well, how do I need to do this? I need to do it like this. I think it's a perfect like picture of new author. Look at that. That is the new author face, right? Like, yay! Or maybe not new author, but like new book. Look at my book, it's published.
Yeah,
it's a nice cover as well, right? Go for it.
yeah, if Dave, Ada, and I get $1 for every late night we spend, we probably have like, I don't know, $120 between the both of us, all three of us. And yeah, and what so happenstance showed that the three birds, like it was like just that.
Yeah, of
I don't
course.
know.
3 authors, 3 birds, right? Yeah, yeah,
Yeah,
yeah.
yeah, and like even I don't know, being able to bounce ideas within three authors has been a real at the dimension. There was that emergent property, I think, between the three of us. Like we thought the book would go one way with like you solve ML problems with better engineering, but we kind of no, actually, it's more product, and then we pull that thread a little bit more, and then actually, it's how teams operate together. So yeah, the three
Nice.
birds was really interesting that we all came together.
Nice.
Yeah, for this.
It's super distinctive. So
there's lots of reflections on three in the book. There's probably three main parts as well. Just like there's just like there's three levels of organizational effectiveness, being individual effectiveness and then individual within teams. And as David said, one of the emergent threads that came out was the between teams effectiveness in organizations as well, as we were writing about what things teams needed to do in terms of team dynamics. Once we'd got through the product and the engineering practices, the team dynamics of working in ambiguous environments and complex environments. We realized that we had to address the factors outside of any one individual team as well, and that's where team topologies was the perfect model to explore that through.
Yeah, because that sense of how teams interact is obviously like one of the absolutely central things inside team topologies, like with the team interaction modes and explicitly not in team topology we didn't really look into a team. We were looking at the interactions between them, and I think it's important what happens inside a team for sure. There's all the team building stuff and so on and so on, but then I think it's fair to say until team topologies and came along, that there wasn't that much thinking about kind of inter-team interactions at least inside IT. I mean, other sectors have done something on it, but so it's good to connect through to that. Cool. So let's just talk a little bit about your the third author who's not here today, Ada. Give her a bit of a shout out.
So Ada is another colleague of ours from our time working together at ThoughtWorks. She's a senior business analyst, and she's worked with us on product development and delivering programs of work that are ML or advanced analytics centric.
And there's something in our show notes here that's fun, right? So the names David, Ada, and David is almost a palindrome, right? And it's the inverse of Ada. As a name. You all fit really well together.
If I happen to be named Divad, it would be perfect.
That's really cool. Okay. So really recognizable book cover with the three orange birds for the authors and so on. Cool. Let's actually dive into some of the. I guess let's start with the kind of the background. Like why in particular? Well, I guess we should start, to be honest, with machine learning. Let's just start with that. Like just kind of brief overview and like history potentially and where it's going, because obviously things have changed quite a bit in the last few years with generative AI but then some of the core ML stuff hasn't necessarily changed very much and so on. So a little introduction there, and then why the book? Like why do we need to even think about effective machine learning teams, or you might call it generative AI machines or whatever, teams or whatever? Why do we need to think about teams in that particular context? What's maybe special or different or awkward or an opportunity in that space that then means it's worth zooming into this particular area with your book? Either of you choose.
I mean, I could start. I guess machine learning's had a lot of airplay recently. It's and in its latest form, generative AI. We can trace it back into the previous century, early experiments with statistical methods and neural networks. They found traction on the web with predictive search and recommendation systems in the noughties as we came into the we had to work around the unreasonable effectiveness of data from Google. I think we then started to see in the 2010s more data available, bigger data sets available, and that started to diffuse through a lot more organisations and a wide range of use cases, using predictive analytics to improve user experience and optimize processes in organisations. So we kind of got to a point, I guess, by the end of the 2010s, machine learning was pervasive, but not necessarily visible in experiences. I think one of the big pivots with generative AI recently has been that while ML and AI applications remain pervasive, they're now very visible with interactive tools like chatbots and LLMs and image generators. So brief history of ML. So it's gradually become a bigger part of what most organizations in the digital space are building over that time.
Yeah. And to add to that, I think the common thread kind of threading across all of these evolutions of applications, ML applications, has been the need for, just rigorous or solid product engineering practices and techniques, like whether it's a recommender system or a car valuation prediction service or house valuation prediction service. All of those experience, like customers will need to kind of just have a dependable system, and if systems are unreliable or not trustworthy, then your kind of return rate drops. And also for the teams delivering it, we've seen time and again that it's not just the ML problem. We may have seen that famous diagram where you've got from Google the high interest credit card of machine learning, where ML was just a little box in there. There was infra, there was data management, there was data labeling, and DevOps and scaling. So ML was a small part of that. And teams trying to build ML products kind of recurringly hit this snag where you can't really iterate fast enough if you don't have that rigorous, engineering excellence, product excellence. So through the applications that Dave was mentioning, like there's just this recurring theme of how do you build a reliable product? How do you build it, with product thinking to solve the right customer problem? How do you build it with the right engineering practices that let you evolve it, improve it as you go? And get fast feedback.
And it's the same story with like application software, right? Which kind of went through the same journey, but like 10, 15 years before, which is more and more my experience and background. But initially it was like the early days of like kind of web applications and stuff like that. It was like you might have just been an individual crafting together some like Perl scripts or whatever, and then over time, we realized we need a larger group of people, so we have to think about version control, and then we have to think about multiple teams doing things, and so on and so on. And we discovered the value of like proper product management and so on, and then cloud comes along where you've got SaaS as a brand new like paradigm which couldn't exist before, and so then there's all kind of how do you manage products in the SaaS, and so all of that product management experience around that kind of software grew up. And suppose
through that process, gradually more specializations got laid into those stream-aligned teams, if you will. And I think that's one of the key characteristics of teams building ML products, that they're adding in even more specializations to be able to work end to end. And so at some point that becomes untenable to manage in a single team. Although single team is a great unit to move fast and deliver under conditions of uncertainty, with the right practices, as David said, to manage that iterative process and experimental process. But it's the question is how to maintain that fast iteration or fast flow as you have more and more specialities to deal with, and generative AI and rise of the ubiquity of it in organizations brings more specializations into play as well.
It can feel frustrating for some folks, like if the my understanding is that a lot of people in the ML space have come out of, let's say, a physics background or computational biology background, so that they might not be primarily like a computer science or like engineer, that kind of perspective. They don't even necessarily see themselves as like being a sort of writing software person. They just write a bit of Python or whatever you use in order to get a job done, and then let's look at the data. The data is the thing. And so then this is my understanding, and I have seen it in some places. There's kind of a tendency, or has at least previously been a tendency, to sort of downplay the value of software engineering practice and wisdom in this kind of space historically. Is that something that is that fair, or am I being unfair?
I think it's challenging to balance the two perspectives. I think it's often easy to get sucked in by the idea of improving model performance over everything else. And so that might be the kind of data science prime perspective. But then if you actually look at delivering a digital product or service, then 1% increase in availability might deliver the same organizational value as 1% increase in model performance. So we really do have to balance the engineering and the data science, and you need to have that holistic perspective of where do we get the most value at any time. But data scientists and ML engineers coming from academic backgrounds, they may not have had the opportunity to work in a multidisciplinary team in short cycles prior to coming into an ML product team as well. And so that's something that we need to be conscious of for successful teams.
This is from my slides the other day, and I think these are the kind of specialisms that you talk about, or some of the specialisms that you talked about before. And this is the kind of the state of play maybe a few years ago, where like there's a cluster of data scientists, that's their background, a cluster of data engineers who are kind of making the model happen, and a cluster of like ML ops people who are kind of running it. And they're kind of clustered into these specialisms, and there's understandable reasons for that. But this then starts to look like the state of play in application software development back in like 2006, basically. So like basically just like repeating the same patterns, because then the next slide here, there's a set of patterns that I pulled together called DevOps Topologies, published them in 2013, but that was based on seeing what was happened before. And so what's that? That's now 10 years ago, when we're kind of dealing with these kind of potential problems. And yes, my understanding is that this kind of handoff is still fairly common in the ML space. Like, what would it take to avoid handoffs? Is it even possible? And that's part of, I guess, what you're looking at in your book. Like,
yes, yeah, exactly. I was just talking to a friend the other day who on starting his new role had found delivering customer insights, analytic insights as part of a digital experience, a complete separation between the front end team and the back end data engineering team. And both of them had been working in isolation for 9 months or so, and trying to put the two parts of the solution together, nothing fit. And then his first move was to say to them, it doesn't matter how long it takes, we're going to push something through end to end. And so we're going to make sure we can deliver a change through that whole value stream. And sure enough, that was when things started to work and things started to become unstuck, and they started to develop some velocity.
And
it's unfortunately too common, but it is easily solved as well.
Absolutely so. And that's what excited me about talking to you, like whenever it was 10 days ago or something. Like the principles and thinking behind your work, your book, and the way that you see things is coming from the same place that all the kind of my experience and the Topologies patterns and things are coming from. It's that sense of, we need to avoid these handoffs. We need to have kind of end-to-end responsibility, because then you get a better connection to the customer and the user, and we can fix things more quickly. All of that kind of learning that to me seems kind of straightforward, but actually to a lot of people is not straightforward at all. And so it's great to have that condensed and expanded then in your book that can speak to people who are in that space. Like, because people in ML, they might not think to look outside of machine learning or data for patterns for how to work together. So being able to target them and say, look, we're in this space. We are your kind of people. Here's what we found is a super thing to be able to pull together. Cool.
But
right,
it's
what should we talk about?
Interesting. Yeah, that there's a lot of different lots of different types of ML or AI people these days as well. So a typical team might include a product manager, as well as data science expertise and some data engineering or ML ops expertise.
Before we forget, we're going to do a giveaway, correct? This is something that David and I were plotting about before you joined, Dave. So there's going to be a giveaway, a book giveaway. So one person who posts in the Team Topologies AI and Data community space will receive a copy of the book at some point. Now, how long it takes to get there will be a different matter because it might have to go around the world. But if you head, I'm going to put the link in the chat. So TT Community AI and Data Space. Can't even type. There we go. So I've put that link in the chat. One of the people, someone who kind of, if you ask an interesting question there, we'll basically pick the most interesting question or the most interesting response, and then you'll get a chance to win a copy. Well, you get a chance to win a copy of the book. We'll pick one question or response, the most interesting one, inside that space in the Team Topologies community, and then thanks to David and Dave, you'll get the person that we pick will get a free copy of this book. So after the live stream, go ahead, join the community, share your spicy take, and you might be in with the chance of getting the book. So thanks to you both for that. That's cool. It's a nice way of bringing it to a wider audience. So we were talking about kind of flow. In sort of ML applications and trying to avoid handoffs and things. Is it worth mentioning CD for ML, so continuous delivery for machine learning? Is that a good time to kind of talk that through? Because that's like continuous delivery. The book came out in 2010. Jess Emble, Dave Farley. You may have even worked with them at the time because they may have been colleagues. I'm not sure in ThoughtWorks. Both came out of ThoughtWorks.
Yeah, definitely looked up a lot to their thinking, and CD for ML is a variant of continuous delivery in the space of ML. So I think they're standing on shoulders of giant for that.
So just briefly, like continuous delivery, certainly the kind of application-centric focus one, it's making sure your software application is in a releasable state, so you could release it anytime, effectively, and you're integrating into the core version control repository at least every day. I mean, there's loads more detail, but that's what we're talking about. Releasable anytime, effectively, and we're integrating at least once a day. So how does that relate to, like, what kind of power does that give? What kind of, if we take that approach, like what does that even look like inside a machine learning context, and what are the challenges? Because there's lots of challenging machine learning, size of data, all kind of stuff. Like what's that look and feel like? Give us a feel for CD for ML.
Yeah, I can paint a picture of a kind of before and after state with one of the teams we worked with. So, prior to introducing continuous delivery in this, ML team that we were working with, we were shipping a predictive service essentially. So prior to CD for ML, number one, the pull request review process, just to take a very low level example, was number one, really long. Like you've got some code changes. Is it working? Nobody knows really until you go manually test it, and nobody has time to manually test it. So sometimes teams, let's say, merge it, and 2 weeks later we find a defect or found that model accuracy dropped, and now there's kind of maybe like, let's say, like 80 commits, one of which could be a suspect, and that led to this issue. So it was really painful, and when it came to release time or deployment time, defects often happen, and also very stressful, especially when releasing to like a million scale traffic type of a lot of customers. You feel a lot of stress, a lot of anxiety for those production releases. So we slowly introduced a continuous delivery, and what that looked like was we have a visual in the book. I'll try to paint it out. Like it's, let's say one of our ML pipelines took 3 hours to train. So sometimes 2.5 hours in, the last step fails, and the data scientists wasted half the day. So we shifted that left, and we could, on a push, trigger that whole machine learning training pipeline with a really small slice of data, and in 1 or 2 minutes, we got feedback to know, hey, this is going to work. Let's run it at scale for 3 hours. And another step up,
which is it's the direct equivalent of a software application build taking a long time. So we're thinking, what would it take to get fast feedback? And we're always saying to ourselves, how can we get the fastest feedback on this thing as soon as possible, so that we know that we can continue? And it's exactly the same principle, right? It's that what's happening is different, sort of, but the principles are exactly the same. We're trying to get very, very fast feedback, fail quickly, and make it make sense to progress to something that's more lengthy.
That's right.
And some organizations even make that feedback cycle a fitness function for their ML build pipeline.
Yeah, that's right. And
I'll share a link after the live stream.
Yeah, every push and every pull request merged is a release candidate, and we at the end of the whole training, we log how good our fitness functions about this machine learning model. And when it came to release time, we know that it's passed in staging, the model's been deployed to staging. We know it's good, like it's not going to blow up in production. And it's not just about the 4 golden metrics. With ML, it gets more complex because the data is also changing. So then being able to look at our evaluation metrics, being able to run evaluation on demand it's kind of like open-close design principle, where your ML evaluation suite is open to extension. You can run it on more recent labeled data, more realistic data, and you can know, all right, this model number 64 is good to go to production, and you got the confidence from that CI/CD pipeline state. So the emergent properties of that team was like, you feel the flow, things get moved along more quickly. There's less waiting in review and things like that. You feel kind of the joy, like there's less stress about production releases, less toil and tedium. So overall, it was really fun times in the project.
And are you one of the big things with this the generative AI models that are open that are being evolved very, very quickly at the moment is the weight. The weight for those of you who are not so familiar, the weights are effectively the parameters that are attached onto different parts of the model. This is going back in time, because this is what I did at university now. This is a long time ago. But the weights effectively are how the model makes decisions or processes the data and so on. And there's been a big push for open weights, a bit like open source. So you've got a model, yes, but then show us what weightings you use at the different parts of the perceptron or the neural network inside there. And there's a European company just published like a whole new thing yesterday. What they call, and they opened all the weights as well. So like it's very like open source approach. It is. When you're doing these kind of ML models and things like this, you're in the context of CD for ML, you're storing that kind of configuration data, like weights and stuff like that. You're storing that in some sort of version control. Is that a thing? Is that the equivalent? Because that's what we do in application software development. But so you're taking all the kind of configuration, like the weights and all that kind of stuff, and that goes in somewhere like version control.
Yeah, that's spot on. So one of the ML platforms we used, like every artifact is persisted in our artifact store. So the hyperparameters you use, even the intermediate representations in the pipeline, whether it's a data frame or a model itself, being able to version that and have every push, every training flow automatically versioned was really good for reproducibility. So if something were to blow up, we can kind of go back to that point with these data, with this configuration, like what caused that bug, and we can see, oh yeah, this kind of customer with this kind of data like really confounds our model. So can we do the error analysis and improve that? So yeah, exactly what you said was kind of prerequisite capability to do better error analysis and triage and have the continuous improvement cycle for the models.
Okay, that's cool. Right, so we've got our foundation in place. We're using CD for ML. We're aiming to get that kind of continuous flow. We've got lots of stuff in version control or in artifact repositories and so on and so on. We've got a pipeline. It can fail very quickly, which is good because we don't want to be waiting for 2 hours to learn its fails. So we're detecting problems really quickly and so on and so on. So we've got all of that goodness, all of that continuous delivery goodness in place. But there's from a team topologies perspective, there's a lot of cognitive load going on here because the data science part is that you've probably got a PhD if you're working in this space, or many people have. Data engineering again is like there's lots and lots of stuff to get to grips with. So at some point we might think, oh, we could just have a single team doing all of this stuff end to end, and it kind of falls down because at some point there's too much stuff to think about. So like that's where the kind of we can use team topologies influence to then shape this whole idea of effective machine learning teams and who does what. There's a good segue into thinking through some of the patterns and that you came up with in the book. So just talk us through, Dave, maybe some of the challenges, some of the specific challenges that then can be addressed by rethinking where the relationship between different teams, like pulling some effectively cognitive load or pulling some activity out to a different team. Can they provide something as a service to another team so that the other team can just focus on a different slice? We were going to hear some of the gnarly details about like what makes this stuff hard, basically.
Yeah, absolutely. I mean, first, I guess establishing that we've seen ML delivered in a single stream aligned team. It's possible to do. That's usually where I guess we'd also recommend that an organization starts if it's totally new to ML, to be able to get that flow. They'll be choosing, I would imagine, we'd imagine they're typically choosing a use case which is very well understood, has lots of supporting examples, and might even be available as a service from one of the cloud providers. So the cognitive load in that case and the risk is going to be minimized. But then,
and that's here at the top left, right?
And that's here at the top. Yes. Yeah.
This is from your book, correct? This is a diagram from the book?
This is from the book, yeah. Chapter 11 in the book. We look at two different primary scaling pathways, which, as you can see from the diagram, can diverge and then converge again, or could move stepwise.
So we start at the top left here. We've got a single machine learning team, end-to-end streamlined team that they're doing everything.
Yes, yeah.
Which is a good starting point, and that's definitely what we recommend in team topologies. Like conceptually, like what if it only needs that team, don't do anything else. Like don't add extra teams just for the sake of it. Like if they can do everything like that with good flow, cool. Let's go with that. But talk us through these other pathways.
What's not shown with that one team though is probably that it's consuming a number of services, digital services as a service, but they're undifferentiated. They're commodity services.
Like
sort of
cloud provider
credit card that any team could consume.
Right. Yeah.
Then I'd sort of look at the horizontal pathway, and this is what we've seen in organizations, where there's one like an additional challenge around ML and AI is there's no single flavor of ML or AI. One team might be using supervised learning, another team might be using like a clustering technique. Another team might be using natural language processing. Yet another team might be using graph techniques. There's a wide range of different techniques, each of which could support its own PhD. But the good news is that these also typically align to business problems to be solved. And so what we've seen in this top right is this pattern of a complicated subsystem team, which owns a kind of a business domain, which has typically has a particular or limited set of ML or AI techniques aligned to that business domain. And so that would be the next set where you see there's a lot of product opportunities in this business domain. For instance, maybe it's your first ML product might have been a recommender system. Now you see a lot more opportunities to understand audience interaction with the products or the services that you offer. And you might build a domain team around audience engagement there, and that might serve multiple product teams. If you have a marketplace, for instance, you might have product teams on the buyer side and the seller side of the market, both consuming from that engagement, complicated subsystem team. They're typically going to, as they're growing and developing, they're going to be collaborating with those product teams to ensure that they're tackling problems for the first time, ensure they're building the right thing. So they'll be collaborating, but there's obviously a limited number of collaborations that team can support. And I think this is where we often see a failure mode, especially when a sort of central team is stood up for ML or data initiatives. That central team, it's probably actually a domain-aligned team. It's solving a problem in understanding customers or finance or product, but it's pretty aligned to a core domain of the business. But then it's asked to collaborate with so many different product teams and other consumers in the business that it becomes overwhelmed. And all of those consumers find themselves waiting for a long time and receiving low quality outputs as well. So the key challenge here is to try and help this complicated subsystem team move away from that collaboration mode and to be able to provide as a service, as it establishes with a product mindset, kind of take the bespoke solutions into product services that other teams can consume in the organization. So that's kind of the first pathway we see.
So it looks like the two pathways end up in the same place, correct?
Yeah. So you would, at sufficient scale, you'll find you have both of these problems. So the first problem is business domains and diversity of ML techniques. And then the other problem is that in general, these techniques need a lot of data, they need a lot of compute, they need to have that available on demand in an elastic kind of way. They need the type of build support that David described in CD for ML as well, in general terms. And so the other scaling pattern is what's the low level technology that any team can consume and can support their ML product development efforts.
Got it.
And so
pathway
that looks like a platform
1A
team.
is like this one at the top is like a business centric way of doing that kind of scaling, and this vertical thing here, 1B, is like a technology centric way, but of course in the end it's a combination of business and technology that we end up with at the bottom right.
Exactly. Yes.
Yeah.
And what's not shown here is you probably have some enabling teams as well at a certain scale. They'll look a little bit like they'll have their own idiosyncrasies. Where I think where a platform team is about scaling known problems, an enabling team is going to start with novel problems and work through those problems that might present differently in each stream-aligned team. But over time, they're also aiming to sort of systematize what they've found and the solutions that they come up with. So a good example might be around responsible AI or privacy or a concern like that might manifest differently in different scenarios. And so it needs a little bit of bespoke consulting to figure out for each team. But as patterns emerge, they could start to be provided as part of the platform.
Yeah. But the key thing you're doing here is you're trying to find ML product team boundaries that work for Flow, that enable those teams to kind of own that thing end to end. Well, end to end in the sense of the flow of changes and model updates and everything else to meet the needs of the users of that product or the value consumers. Yes, there's a load of stuff which is effectively provided elsewhere by an ML platform or by an ML domain team, but that's good because then it allows the product team to own the end-to-end flow, right?
Yes, precisely. Yeah. We sort of see those boundaries to product or to platform or domain team as change of cadence, so things that aren't changing as fast as in the stream-aligned team.
Yeah. And for things that have been locked down effectively, like things that we can provide as a service, almost by definition are things that are better understood and that shouldn't need to be changing all the time. There's just, it's like a fundamental thing, which I guess in the Team Topologies book, I think we probably didn't unpack enough. But if you're relying on something which isn't fundamentally stable and is always changing, then it doesn't provide the stability. Like just as it would be like a platform that you stand on as a human being, like a platform on the stage. If that's wobbling like that, then it doesn't act like a platform. Like the whole point is it's supposed to like provide some stability so you can build on top of it, right? And yeah, in this kind of diagram here, the enabling team is going to be working across these multiple different teams, detecting problems that might relate to instability, for example, and so then helping to change what's provided by the ML platform or by the domain team in a way which then makes things more stable, if it can do.
Yes, yeah, exactly. Yeah, we might say that enabling team's job is to make it self-redundant for a particular class of problems, and shift those into the systematic solution.
Although, thankfully, if you're working in the AI space, AI and ML space at the moment, you're not going to be redundant anytime soon. Like it's not that kind of redundancy, right? There'll always be something new you have to learn. So the enabling team can be ahead of the curve, learning all this new stuff, imparting that knowledge and wisdom, helping the other teams to skill up.
Exactly. Focus on
it's a good
solving
place
the
to be.
next higher value problem. Yeah.
Exactly. Okay. What else do we need to cover? Handoffs. Is there anything else that you want to share, David or Dave, that we've not covered? I mean, there's loads, right? But everything that really stands out that we haven't talked through yet. There might be a diagram.
One thing that comes to mind is the human aspect of how we build ML products. So I think we see this cycle of teams falling into the same traps. Like you don't have the right product discovery or customer practices, then you end up, let's say, just, spending a whole delivery team's time on a product that doesn't go to market. It's kind of POC hell, let's call it. And over time, you work on 1, 2, 3 POCs, and you get bored, and your most talented people move on, and then you're gonna start again, getting onboarded, and so that's an example in product, delivery, discovery, product prioritization practice. But same for engineering, same for tech debt, same for cognitive load, and all of these kind of pain points come to the kind of lead to a point where the team working on it is not kind of in a healthy space. There's a lot of stress, maybe motivation isn't there, and contrast that with some of like these tried and tested practices. If for example, just thinking about desirability, viability, and feasibility, like that's something that also is almost bread and butter in product engineering or product delivery. We work on something. If it's desirable, we test that with users, we've shift that feedback left. So I think there's a set of these, like maybe product hygiene, engineering hygiene, even ML hygiene, kind of basic practices that we can all practice today and become healthier teams, and spend our organization's time and effort in things that will ship and make our business better off, help our customers, things like that. And so that I think attention to that human aspect of how we build things, not just build the right thing, not just build the thing right, but build the thing in a way that is right for your teams, the people in your organization, creating the right systems so that you get the feedback you need, you get the systems of work that helps you build the right thing. So yeah, it's a lot of kind of concepts over there, but I think it kind, as we wrote this book, it kind of kept coming back to these I don't want to call it basic practices, but these fundamental practices that will help you get off to that good start with the team, to deliver value incrementally, iteratively, and feel the joy and flow of building these products.
And that's that thing about starting with the value to the user, starting with their needs and working backwards. It's to me and you two, I'm sure to Ada as well, like it makes a lot of sense. Like we've probably been working that way for a long time, but to lots of people it's not a familiar way of working at all. And of course, like the Streamlines team concept in Team Topologies, like part of the purpose of that, it's not just from Team Topologies, right? It's from kind of like the whole DevOps movement and everything else. But that principle of being as close to the customer as possible, understanding their needs and be able to iterate very, very quickly, like that's how we can get to this point where we're building just enough. We're building like an ML model, which is just enough. It doesn't need to be bigger. It doesn't need to be more complicated. We're building just enough to meet that specific set of needs, and then iterating very quickly. We've got CD for ML in place. We're able to get that flow, and suddenly way more nimble. We're able to get that change out in like a day, rather than waiting weeks and weeks and weeks to build this huge great thing, which turns out not to be needed. And that level of nimbleness there is like such a powerful capability in the organization, but like it's really counterintuitive to a lot of people if they're coming from a different kind of background where they're used to working in more kind of functional silos and so on. I've just found a diagram from I think it's from your book. It's from your slide deck anyway, which just goes back to the role of the enabling team, because it wasn't on your previous diagram. It might be worth just having a look at that. How do I do this? There we go. This thing here. Oops. Oh, I see.
You can do the builds, and I can talk through.
Yeah.
So this was, we did have this question of, we see guilds or communities of practice, and how do they fit into the team topologies model was the question. One of the questions we were trying to tackle here, realizing that they can be really effective mechanisms for sensing or responding early to some signals in the organisation that there's something interesting to deal with. And so but the problem is, because they're not a formal team mechanism, they're not actually a good vehicle for getting anything done, because people are contributing part of their time, and it's often a labour of love and interest, but they'll have day jobs and other priorities to do. But the guild or the community practice when it comes to novel problems, it's a great mechanism for establishing networks, identifying people who are interested, sharing, learning, to kind of bootstrap what then might become an enabling team, which can help multiple product teams through collaboration, facilitation, to solve those problems. So there I've talked about unknown unknowns or known unknowns for the product team, and for an enabling team to work through with product teams. And then, as those patterns come out, as I said before, we can systematize what the enabling team is doing into platform features by harvesting those common solutions.
I really like this, and I like the way that you've laid it out. It makes so much sense, and when I saw this, I was like, of course, this is exactly the flow, because this speaks to my experience as well. This is exactly what happened with guilds and communities of practice. Is we could talk about, typically the people inside guilds often are the people who really care. They really care about a particular topic. They care about developer experience, or they care about data quality, or they care about whatever, logging, application logging, whatever it is. They care about that stuff. Come together. They're the ones who are going to complain, saying this stuff is rubbish. This is awful. Like, how can we possibly doing it like this? Okay, it's an early signal. We might not be able to do anything, but we're bringing it to the light. We're shining a light on that thing. Okay, looks like can we agree? It's good to get an enabling team around that. Okay, great. Let's go and fix it. I just love the way you put it together.
Fantastic.
I might have to borrow that.
You're welcome.
Is this in the book? Oh, this is just your slide.
I don't know if this diagram's in the book. The description of this process is in the book, but in putting it into a slide, I had to actually, really hone it down and whittle it down to something as clear as this.
I love it. I love that. In fact, to be honest, like, if it'd be great to carry this particular thing further, if you would like to specifically talk about this loop in general. I mean, it's not necessarily specific to machine learning, right? But we could link it to that. But like as a general thing, particularly with the guild and community practice linked in there, I'd love to like explore that more, because it resonates with me hugely in the stuff that I've done.
Likewise. I think a lot of the things here that we've used machine learning as a foil or an example apply to any kind of specialization in an organization equally.
Because it's knowledge work, right? It's awareness, it's processing information, it's representing intent in computer systems, and it's the same kind of work. There are different dimensions to it which look different, volumes of data or whatever, but like the nature of the work is basically the same in all these cases.
Yeah, and different problems that all teams might have to deal with that you might want to offload to a group of specialists to improve the flow of those individual teams.
Cool.
Off the back of that, Dave, I was wondering if you wanted to speak to that slide with that visual we had with the layers for chapter 10 and 11, like the within team and how you scale it across the team. That
The effect of the building blocks.
Yeah, I don't know, Dave. Do you think like
yes, yeah.
how do we scale ML across
This one.
a big domain in a big organization? How do we scale ML at different levels? Do you think it's worth talking through that, or?
Yeah. Sorry,
Feel free to
you're talking about this diagram, David?
Yeah.
Is this the right diagram?
Yeah, this is the one.
Yeah, great. Yes. I think we talked before about the pattern of threes in the book, and one of the threes is the individual within teams and between teams. So we look at a range of technical practices and product practices, but we also look at kind of team dynamics here on the lower end of the stack. And so again, dynamics relevant to any team that's multidisciplinary, that's working under uncertainty, and learning as it goes, but with some degree of pressure to deliver something valuable at the end as well. And so we sort of looked at how we could build up from lower layers to higher levels. That having trust between teammates is fundamental, and a system of work that supports that trust, by externalizing thinking and making objective tests through a CD for ML process, for instance, so that the team can come together collectively around that artifact that it's building. That those sort of practices are really fundamental to trust, but also the interpersonal dynamics, so getting to know one another. Unfortunately, in with some of these specializations, we tend to see an expertise bias, like a damaging expertise bias in some cases. We want everyone to feel like they can contribute equally to the product that the team's delivering. So really deliberately focusing on trust there, and being able to communicate, finding the right channels, be it through the build process, and PRs might be a really good communication process for some things. Other things are going to be face to face. That again, coming back to what we know works for teams solving complex problems. Diverse membership is really important to avoid bias and getting locked into a particular framing. And then being able to have that, as we've talked about flow, we've talked about doing the smallest thing, getting some feedback, doing the next thing, having some way to see progress, purposeful progress there as well. And we know from research that that's one of the things that makes people happiest in their jobs, if they can see a small amount of progress day by day. That's one of the major determinants of whether they're happy. So that comes back to the humane nature of building it in a way that's right for people as well. So those were sort of within teams, some of the really fundamental building blocks that we thought were important to call out. And then, also, within teams, as we start to go from within teams to between teams, then exactly those, how do we manage that cognitive load and maintain that flow state that we have within one team, and feedback? That's a critical question about how we break things down. But then we also identified some other enablers for a team topologies model for an organization at scale. And one of those is ensuring that the enterprise portfolio of work is structured in a way that autonomous but aligned teams can work under that portfolio. And there's a model, the lean value tree from the Edge book, which by Linda Liu and David Robinson and Jim Highsmith, which is a great model that allows autonomous teams to deliver an alignment towards an enterprise strategy. So then we've got organizing teams for fast flow, the team topologies model, and then we've also got leadership on top of that. So that's another kind of cross-cutting concern. Often, we've seen a lot of ML and data organizations where leadership isn't aligned to the flow of work. So although we might try and put teams together that are flow aligned, they might report along functional lines to different leaders in the organization. And so, there we've also tried to explore how leaders can work in that environment together, as a team of leaders, but also recognize the flow that cuts across their organizations.
It's really cool because I love this diagram as well. Again, I'm going to have to borrow this with attribution, right? sometimes called stealing. No. I'll point back to you, because there's nothing in here I think which is particularly specific to ML teams. I think this is the nature of the challenge in general, and it's a good call out to the book Edge. I did a webinar with David Robinson about 2.5 years ago, I think, where we compared the Team Topologies book and Edge and the ideas, and super compatible. So that was nice to be able to do that. Just before we finish, there's a couple of questions from the chat which you may be able to answer really quickly. Let's have a quick look.
Okay.
Here's one from Krishna Kumar. Are there any books recommended for business leaders to embrace AI journeys? Do you know of any? We might try and answer it in the Team Topologies community if you don't know any off the top of your head.
Yeah, we can put together some recommendations.
That'd be afterwards. Cool. We can drop it into the community later. So we'll try and do that, Krishna Kumar, a bit later. And just a comment here from Nick. We need to write an article about applying Team Topologies to data and ML work. There we go. So Nick, hopefully this is useful for you. Thanks for commenting. Appreciated. Hopefully we can inspire you, and just let us know when that's live. Pop something in the Team Topologies, the new AI and data group in the Team Topologies community. That'd be brilliant. Like I mentioned, there's this new Team Topologies AI and data space. Follow the link from LinkedIn is the easiest way to do it. And let's get talking. And where else have we got? There's a question. You've answered it already, David, slightly. So this question from Nicola: what have you found to be helpful to bridge capability gaps between data scientists and software engineers and ML product teams? And you've already responded. We can put it up here. Do you want to just speak to a tiny bit about that, David?
Yeah, that's a great question, Nicola. And in our experience working with data scientists and ML engineers, like most folks we work with enjoy that fast feedback, that reliability, that ability to deploy with low stress. And so I think that problem becomes then information asymmetry. It's not that they are resisting this information. It's just that two worlds have collided, the data world, data science world, and engineering. And so we are seeing more and more of this diffusion in the ML ops space. And in your organization, I think the more we can show that a team with the right product engineering team practices can ship faster, be healthier, deliver more outcomes, then that is a great standard to set. Then how do we scale this practice? Through exemplar teams, through knowledge sharing, through kind of checklists to say, okay, this is what we do when we productionize the system. Because if we don't follow that, we'll get it will come back to bite us when we have silent errors in production and things like that. So yeah, I think if the resources and the material and people are there, then I think shaping that to show what good looks like, more collaboration and more fast feedback and scaling through, practice and learning by doing, that has always been helpful.
Thanks, David. Just before we finish, I'm going to pop a link to your book on here and just share this. There's the Three Birds book. Very, 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 very distinctive. Search for effective machine learning teams. You'll find it's published by O'Reilly, and yeah, one PDF. Is it PDF? One ebook copy of your book. We'll choose a comment or a question from the Team Topologies community for that lucky winner. So thank you for everyone who's attended. Get your comments and questions into the Team Topologies community. That would be cool. And we're done. So I really appreciate it, David and Dave. Thank you for joining. I've learned a lot. I was inspired by the couple of diagrams there. It's brilliant. Thank you very much. And let's continue the conversation. There's plenty more to follow up on here, particularly with the whole thing about generative AI and the effect that's going to have on how we build software and even models and a whole lot of other stuff. It's going to change the dynamics. It'd be great to follow up at some point.
Oh yeah, I think there's a whole nother podcast in there.
Yeah, at least one. It'd be brilliant. I really appreciate it. Thank you both. Have a great weekend. Enjoy yourselves.
Likewise. Thanks so much,
Thanks a lot, Matthew.
Yeah.
Thanks everyone for your
See you next
questions.
time. Thank you.
Yeah.